we are going to hear about Rosella Telaretti Leggieri, I hope that I'm pronouncing that correctly, from the Swedish Environmental Research Institute and the Tornado Project. And she's going to talk to us about fluorine-free coatings for textile, kitchenware, and packaging applications.
Okay. First, thank you very much, Chiara and Estella, for organizing this workshop and for inviting me to talk about our experience with SSbD in the Tornado project, which is currently getting close to its conclusion. My name is Rosella Telaretti Leggieri. I work as a researcher at the Swedish Environmental Research Institute. And IVL is a research and consultancy organization based in Sweden. It's Sweden's leading organization for applied research and in the environment and sustainability. So at IVL, we have expertise in toxicity, ecotoxicity, risk assessment, life cycle assessment, and chemicals, so including chemical footprint, and we apply this expertise in SSbD projects. So apart from Tornado, there are other projects that IVL participates in or leads, and since I will mention some of these later in the presentation, I have listed them now. And they are, for instance, IRIS that you have heard about from my colleague Emma. Mistra SafeChem is a large research program that aims to create a sustainable chemical industry and reduce exposure to hazardous substances. ToxReduce focuses on chemical footprints and the tools for doing chemical footprints. PARC is the partnership for the assessment of risks from chemicals, so focuses on risk assessment and includes also activity concerning SSbD. And then we have Chem@Sustain, focusing on nanomaterials, and Bioplastics, focusing on textiles. But let's dive into Tornado. Tornado started in early 2023. It's funded under Horizon Europe Research and Innovation Action, and the consortium has organizations and companies from Spain, Turkey, France, Italy, and Sweden. So as for the timeline, I wanted to stress that Tornado started quite early in the timeline of the development of SSbD. It will end in the spring of 2026, so quite soon. So the proposal was written in a very early stage in the timeline of SSbD. And this obviously had consequences on how the SSbD assessment in the project was conceived. And as for some background, today there are great concerns over the impacts of PFAS, and polyfluoroalkyl substances, on human health and the environment, as already mentioned and introduced by Pau earlier in this workshop. So regulatory restrictions are in place and more are expected. And this has created a pressing demand for benign alternatives within coating applications where PFAS are commonly used. The Tornado project aims to develop novel fluorine-free and thus PFAS-free coatings that are expected to have water and oil repellency performance and which are safer and more sustainable than current PFAS-based coatings. And to ensure that the novel coatings meet safety and sustainability criteria, the innovation proceeds in parallel with a full SSbD assessment. The targeted applications in Tornado are food contact packaging materials, kitchenware, and that is frying pans, and textile. These materials or products are then tested for performance, primarily in terms of water and oil repellency, but also for migration to food. And the validation of the product is carried out at technology readiness level, TRL 5. As for the composition of the coatings, the idea for the tornado coatings is to produce monomers by functionalizing acrylated vegetable oil, and specifically soybean oil, with siloxane structures. As you can see in this slide, PDMS and POS, one is linear and the other has a caged structure, resulting in partly bio-based monomers. So the monomers are then copolymerized with methacrylate and acrylate monomers via emulsion polymerization processes. And finally, the polymers are included in coating formulations. Now here is an overview of the life cycle system and system boundaries of the assessments in the Tornado project. Going from raw materials production in the left side to the processes framed in yellow and red, which are the processes developed within Tornado, from production of monomers to polymerization, and then preparing the coating formulations, and then application of the coating formulations to substrates, and finally use phase and end of life. So for SSbD step 1, the hazard assessment, we assessed in Tornado all chemicals involved in the processes developed in the project. So we have a shared file for the chemical list, and there a challenge is that obviously the plans change over the course of the project, and then obviously you have to keep the assessments up to date. So the hazard assessment cannot stop in the initial phase of the project as it was thought in the proposal at first. Then we have step 2, the risk assessment in the production processes. Step 3, the risk assessment of relevant scenarios of exposure in the use phase. And finally, the life cycle assessment and social LCA are conducted by partners in the project, IMEN in Spain, and therefore I won't dwell on SSbD steps 4 and 5. But now, so as for the hazard assessment, and also biodegradation, actually. So from the start in Tornado, we knew that we would need hazard data and more input data on materials that are developed in the project, and there or uncommon chemicals that we wouldn't be able to find information on. So we knew that we needed in silico predictions. And for that, we have used the Mistra SafeChem in silico toolbox, which is developed. It's software including different models developed within the SafeChem project funded by the Swedish Foundation for Strategic Environmental Research, Mistra, and led by IVL. So these models allow for the prediction of various endpoints, such as hazard endpoints, both for human health and for the environment, carcinogenicity, mutagenicity, reproductive toxicity, and so on. Basically, all the relevant ones, including endocrine disruption. There are models also for predicting biodegradation, bioaccumulation, and persistence. There's also 2 sets of models that predict the H statements, the hazard statements according to the classification, labeling, and packaging regulation of the EU. And finally, also under development, a model for predicting biotransformation. And so using these models, we have been able to predict hazards and other endpoints for all the chemicals involved in the Tornado processes. And this is how the interface of the tool looks like. For each endpoint, substances are assigned a score which ranges from -1 to 1, where positive values mean that there is a hazard. Negative values mean that there is no hazard for that endpoint. And higher absolute values mean a greater confidence level in the model. Lower absolute values mean a lower confidence level in the model. And for each endpoint, the final score is calculated as the average of all the scores non-zero assigned to that endpoint. And the score is visualized by means of colors, which range from green to red, including yellow, which means lack of data or inconclusive assessment. So by using that software, we can create a heat map, as you can see in this slide, to easily visualize the hazard associated with all the chemicals investigated. Now, this is a selection of chemicals in the processes. Here you can see that there's quite a lot of yellow, which again means lack of data or inconclusive assessment. And I would like to mention that the models are trained on available hazard data and biodegradation data, and so on. So as already mentioned by Pau earlier, we really need more and improved databases, even just for using the predictive models, because they need to be trained on those data. So if we don't have the data in the databases, we can't have reliable machine learning models to predict those data. And so some results, we have unfortunately identified quite a few substances of concern among the chemicals used in processes in Tornado. And here we have encountered the challenge that the coating composition and to a largest extent the processes in Tornado were set from the start of the project without really space for changing very much. And therefore the redesign stage based on results from the SSbD assessment was not really possible in this project. So we have realized that for future proposals, applications, it would be good to leave out some space for flexibility in this sense. So structure the project in a different way and allow for a timeline that makes sure that the assessments start very early and then give feedback to the manufacturing work packages, so that they can basically optimize their processes also based on safety and sustainability. Then I will move on to SSbD steps 2 and 3, just an overview. So here we conduct a risk assessment, and if anyone isn't familiar with this, I will give a very short introduction. So here the aim is to model human health and environmental exposure to chemicals in the manufacturing phase for SSbD step 2 and in the use phase for SSbD step 3, and quantify the risk. To quantify the risk, the model exposure is divided by an ecotoxicity reference value, and risk characterization ratios, RCRs, are obtained. These RCRs indicate whether the risk is considered acceptable or not. So an RCR below 1 means that the risk can be considered acceptable, whereas an RCR above 1 means that the risk is not adequately controlled. So far in Tornado, we have applied the CHESAR tool developed by the European Chemical Agency, the Chemical Safety Assessment and Reporting tool, to model exposure and calculate RCRs. And that method or model includes different models, the SETOC TRA worker tool for occupational exposure, and the SETOC TRA consumer tool. And finally, for environmental exposure, the uses model. just a selection of results to show what we get from these models, and specifically for human health exposure in SSB in the manufacturing phase. Here I have reported results for the copolymerization process, and you can see that the graphs include the chemicals that are used or produced in the process, and different colors are assigned to short-term inhalation, risks, long-term inhalation, and long-term dermal risks. We can see that the main risks are for short-term inhalation, and for some chemicals we have RCRs that are above 1, which means the risk is not adequately controlled, and this can be fixed by improving the risk management measures. And this happens especially in steps of the process that allow for more exposure. For instance, in the bottom right side sampling. But also it's interesting to see that in the top two graphs, we are comparing this copolymerization process done via a semi-continuous production to the left, or a batch process to the right. And we can see that the batch process leads to an RCR above 1 for one of the chemicals listed. So here it's an easy fix, and this has happened in the project, that the semi-continuous process has been preferred over the batch process. And then just to mention briefly, we are currently assessing the risks in the use phase, and the exposure scenarios that we are evaluating are the following. For the kitchenware application, we are evaluating human oral exposure via migration to food, whereas the environmental exposure is assumed to be not relevant in this context. For the textile application, we are evaluating the environmental exposure from emissions via washing and weathering, whereas the human dermal exposure is assumed to be not relevant because water and oil repellent clothes can be considered to be more applicable for outdoor clothing. And finally, for the food contact packaging application, we are evaluating human oral exposure via migration to food again, and the environmental exposure is assumed to be not relevant. As for the aggregation of scores from different assessments to get to the final SSbD score, we are following the methodology proposed by the Joint Research Center, JRC, and we are thinking of applying and testing the PARC SSbD toolbox, which was previously mentioned by my colleague Emma. So you can absolutely get in touch with the PARC project to get access to this toolbox that you can use online. It includes various tools and databases that you can directly use in the tool, and it allows for adding also scores. For instance, from the LCA assessment, you have to add manually the indicator results at this point. And finally, it allows the user to aggregate the scores very easily. A few take-home messages. We have definitely realized that in research and innovation projects, it's often necessary to rely on the use of prediction tools for instance, hazard and biodegradation endpoints, due to the fact that new or uncommon chemicals are used or produced in the processes. And there is a need for further development of these tools, and also for building competences in the use of these tools, also to understand how they work and what the level of uncertainty is and how to deal with that. Then again, hazard and biodegradation and more data in the ECHA database is often insufficient, both for conducting the assessments and for using it as training set for prediction tools. And this has emerged in, I think, many projects and case studies. And finally, we have highlighted how SSbD-related projects need to be structured in a way that allows for space for redesign based on the results from the SSbD assessment. Finally, I would like to acknowledge the funding from the European Union and acknowledge and thank all the Tornado partners and the other IVL project members. Thank you for your attention.
Thank you very much, Rosella. That was a very good final presentation that I think rounds up everything that we have been hearing today. And I think that I keep hearing is the lack of data. Obviously, this is without data, it's very difficult to do it from any assessment. Any prediction and the prediction tools cannot really obviously operate to the maximum of its capacity. So now we're going to have some questions that they already popped in the chat. You can still all write, of course, follow-up questions in the chat. We will have around 15-20 minutes of Q&A, and then I'll pass the floor to my colleague Chiara. So here we have, first of all, a general question from Rob at the beginning of your presentations, Dimitris and Rosella, and then perhaps I just we just go through it and let's see how are you how this question can be answered by you or by Emma as well, and Pao if they want to join, because since it's a general question, I think this is a good icebreaker for this Q&A, this second one. So first of all, maybe we go with Rosella first, that just finish speaking. Every chemical product contains impurities. Bio-based materials also contain impurities, but different ones to petrosourced products. At what level percentage should the SSbD analysis take the impurities into account? Wow, that is a difficult question, I think. Yes.
Very interesting. I think from my experience, I would say that all impurities should always be taken into account. I must say that this might be more of a perspective from chemical footprint than from the risk assessment perspective, because in anyways, we know that even small amounts can result in hazardous effects. So I think it should always be evaluated, and then if one can conclude that the small amount is insignificant, then it can be excluded. But I wouldn't exclude it from the start.
Thank you. That makes a lot of sense. Rosella, maybe I don't know if any of the other speakers today want to answer about this. Dimitris, do you want to add anything what Rosella said to this question at all, or shall we move to other questions?
We can move on the other, just
Okay.
to add that, of course, everything is based on the data that we receive. So let's say the challenge here is about how can we move from lab pilot activities to the scale lab. So always we have to take also into consideration this one and in our approaches. But I fully agree with what Rosella mentioned about the approach in the different stages of the SSbD analysis.
Perfect. Very good. Here we have from Guillermo a question to Dimitris or Rosella. I would say both then. I'll take the chance. So maybe starting with Dimitris, SSbD framework proposes certain tools to perform risk assessment for step 2 and 3. Have you used any of them to address steps 2 and 3? In that case, what do you think is the easiest or more comfortable tool to perform risk assessments?
Should I start?
Maybe you start, Rosella, and your mic
Yes.
is on. Yeah.
Yes.
I think that the next question is more relevant also about the DPP. So
Okay.
then
we split it like this. Rosella, go ahead, please.
Yeah. So indeed, we have decided in Tornado because for the hazard assessment, we have done quite some development and found our own approach. For SSbD step 2 and 3, instead, we decided to rather test what was suggested and recommended by the JRC and the Commission. So we have used the KESA tool, which is commonly used for risk assessment under REACH. And it depends maybe a lot on what one is familiar with, but in general, KESA is rather easy to use. And then obviously one has to consider that the results might be improved by using more complex models. But I would say it is easy to use. I think the guidance could be improved because we have still had some doubts about using it. Yeah.
Thank you, Rosella. And the next question, it's indeed much more targeted to Dimitris. So regarding DPP, Digital Product Passport, would it be possible to import a certain database? Here's an example, EcoInvent, into a DPP digital platform. Assuming you have the corresponding license, do you know if exist any guidelines in order to perform a DPP, and also to know what is the specific information that a DPP should have?
Thank you. Thank you, Estela, for this question. So, first of all,
from Guillermo,
regarding
the question is from Guillermo.
to Guillermo, of course, to Guillermo. So, just first of all, about the databases. Yes, this one is also our vision. Of course, having all the licenses and all the appropriate licenses in order to use. Of course, in the DPP, and how also is what is our approach about the architecture. We can incorporate in databases, and not only equipment, but also other databases in order to get data directly from them. But this one's, of course, it's got the license and is proposed. Of course, we can incorporate any database that, for example, we can find this one based on our synergies with industrial stakeholders. But this one's possible. Now, about the next question and about what the DPP should have. There are guidelines about the DPP, but also for the ESPR that contains this information. And of course, we have to provide product specific information, such as, for example, the material composition, the safety and health data, environmental impacts, and the end-of-life options. So this one will be, as I mentioned also during my presentation, an ID for the product. So should contain all of this information in order for someone to understand, in let's say simple words, to understand where, how this one produced, and how this one can be treated by the end of its life. So this one is what the DPP should offer. A full, transparent, let's say, traceability, if I can use another, let's say, terminology. Thank you.
Thank you, Dimitris. We have then two questions, and one after the other for Rosella. From Sepe, apologies if I missed this, but this early warning hazard screening tool you use for the hazard profiling, is this something you developed yourself at IVL, or was this a tool from the Park Toolbox Kit?
It is a tool that we developed at IVL and within that other project, Mistra SafeChem, that I have talked about, but I could maybe share again.
Yes, go ahead.
Just 1 second. Okay, so the second project listed here, I hope one can follow the links from the slide already. If not, I can add it to the chat. So within that research program, we have developed an in silico toolbox that includes different models. And then I had another slide where, yes, where I explained what, okay, perfect. In this slide at the bottom left, I have the link to the toolbox. So unfortunately, so far, this toolbox is available for members of the project, but I think like there's always space for collaborating. So if interesting, please contact me and yeah, we can discuss further.
Thank you, Rosella. It'll be good if you, of course, we will, after the workshop, we will be sharing the proceedings of this with the contacts of the speakers, if they allow to, and otherwise you can put in the chat, Rosella, and there will be a recording of this, so there will be opportunities for you to engage, in this case, with Rosella on this. Another question, and he answers, okay, perfect. Thank you for the clarification. I will keep it in mind. Another question from Rob to Rosella. In the table on one of your slides, so maybe don't put away your presentation just yet, all compounds were red in the toxicity column. That is probably true. As a toxicologist, we are trained that everything is toxic. But is it maybe not very useful for an assessment? Do you think a benchmark or external control could be used in the assessment, or how could this be judged in a more scaled way?
And it was here. So yes, very good point. We are talking about this fourth column, toxicity. So I would have to double check with my colleagues who work more directly with this hazard profiling. But as I understood, I think this toxicity endpoint basically collects information from any of the other endpoints related to toxicity. I don't know if it's clear, but basically it becomes red if there's at least one red endpoint for that chemical. And I think it's only used for being able to say if the chemical is PBT or PMT. So then you consider it for putting it together with persistence and bioaccumulation or mobility. And that is the toxicity that is part of that hazard classification. So I don't know if then this already solves the question. I'm not sure. Because we don't just use this category for saying then it's toxic. I think it's only for saying whether it's PBT or PMT. And then we specify the other endpoints for each chemical. But an external reference, well, I would have to, I think about it and report. I will definitely report this feedback to my colleagues.
Thank you. That's a very good input that you get also from the workshop. Thank you. I don't know if anyone has any other questions that they want to put into the chat. After the Q&A, we will have my colleague Chiara and speak more about the cluster of projects that we have established. If not, I might have a question that goes a bit off of the box from what we have been hearing. It will be for Dimitrios in this case, from the BioCode project. The digital product passport. This is something that has been that has been going around in EU policy and regulation as something that that wants to be established and is established by regulation, and that will have also potentially a policy impact. How do you think that the DPP could inform EU policymakers and regulators in identifying the safe sustainability trade-off for setting then research and innovation priorities? Do you think that this can have a policy impact beyond, will have an impact on policy writing?
Yep. Thank you, Stella, for your question. Of course, when we talk about traceability, when we talk about transparent, I think that those keywords are relevant to policy. So when we can everything that we discuss also in the day workshop about all these approaches, the results, and if we can have this one under a framework, a digitalized framework, of course, this one can contribute to the policy and to provide some insights to the European Commission, how can be not only to perform the results, but also how you can monitor, how you can evaluate and monitor, and in a transparent way. So this one is our approach. Of course, the Bio4Code project is a real project, it's a research innovation project. So here we do research, but we hope that by the end of the project, we can provide those guidelines to the European Commission based on our research activities. How can they incorporate this DPP in the policy framework, and how they can in the future can monitor and evaluate the products in a transparent way. Thank you.
Yeah, so this is the last intervention for today. So we're probably finishing earlier than 1 o'clock, and that's great for everybody. This is just to introduce you to a concept. So Stella was talking about this cluster at the opening of the intervention. My name is Chiara. I work together with Stella at European Bioplastics. We are a trade association, as I said, European Bioplastics. We are involved in a number of projects, and the Bio4Code project is one of these. The Bio4Code project was approved at the same time with another project that is called Blue Coat, that is led by University of Birmingham, and the coordinator of Blue Coat is also coordinating an additional project on coatings, and that is called Supreme. So at some point, when we started the discussion how to collaborate across these projects, we decided to create a memorandum of understanding and to put it together so that we can create some sort of formats all around the projects and bring experts to talk to each other and to share the consolidated knowledge, ask new questions, and then move forward to, let's say, with one voice when it comes to, let's say, move the policymaker into the direction that we're heading to together. So if you are working at the moment in your university, research organization, or company as well, for a project or an initiative that is focusing on coatings, on sustainable, bio-based, and circular coatings, that's the keywords, the 3 keywords, we would like to hear from you. And if you would like also to participate in terms of a lead into one of these webinars and workshops we are going to organize, maybe we can go back 1 second to the previous slide. We would like to hear from you, and because we would like you to become part of this cluster. So the point is, like, you can join anytime as a participant, but we would like somebody to, let's say, rotate on the lead, the thematic lead of the topics that we're going to choose for the webinars, for the next 9 webinars, and for the 2 technical workshops we're going to have in person. So if you're interested in joining this kind of initiative, I will put also here in a link in the chat. This is the memorandum of understanding that we set up. And also the email address of Stella and myself is the one that you find here on the slides. You can contact us any time and flag your interest to join us in the cluster. Now we can move to the next one. So if you would like to either join as a member of the cluster or not, you can join us in any case for the upcoming activities. Stella said that we're going to have one of these webinars with a schedule of every 4 months. So the next one will be in spring 2026. And we will promote this kind of events in two ways. The first page is actually the page on the European Bioplastics events. There are driven events from research and innovation projects. The second one is going to be the Bio4Code LinkedIn account. That is, you can follow it on LinkedIn as usual. So this is where you can connect, and we will promote events there also to our colleagues Loli, and she's in the line as well. And then we will also use the European Bioplastics account. And the next one is we would like to thank you in any case for participating today to this type of discussion, this type of format. We are testing new formats, so it's good for us to also have a feedback if you liked it or not, if you find it useful or not. So please get in contact with us anytime. And if you're interested in, let's say, stepping up your participation by becoming a member of this cluster, it's absolutely for free. The cluster is facilitated by us. We just need to understand which topics are the burning ones for the people working on the coding community. And the last invitation that I got for you, we have our annual conference at European Bioplastic on the 2nd and 3rd of December, with some side event as well on the 1st of December. So if you happen to be in Berlin, if you're planning to join us, this is still time to register. And if you would like instead to follow online, there is also an online participation that is possible. So this is just to promote a little bit what we're doing as a trade association, and the program is quite interesting this year as well. So I would like to wrap this up. If you got any question related to the cluster, we will leave it to you with the email address. So just get in touch. You might need to check if you're interested in any case, what kind of level of participation you would like to offer. We're open for discussion. And as I said, this is an absolutely free activity that it's funded for us under the Bio4Code project, but we're happy to take a little bit more leads on board for driving the topics in the way you want to steer the topics. And I think this is all. I just want to thank everybody for, let's say, being here today. And we will make, in any case, the recording available. Give us a little bit of time until Friday to share also the proceedings, share the recording. Some of the presentations will be made available, some not, because they contain confidential data. But we will get back to you in the next few days through the emailing list of the Eventbrite to get in touch, and also to check if there is any interest in following up this kind of formats for the spring next year. So, yeah, any final word, Estela?
Thank you very much. Thank you very much. Thank you, Chiara, for the organization of this webinar. She's the brain and the force behind. And thank you to all our speakers. Thank you very much. And we look forward to meeting you again online. Have a very nice day.
Bye. Thank you for joining.
Bye.
Bye.